Today we are going to continue to look at frequency tables or two-way tables and talk about some other things that we can calculate with them. So in this situation, right, due to a shortage in bus drivers, the Fayette County School Corporation is adjusting their bus routes. So they recently conducted a survey of high school students who live in 3 different neighborhoods. And then they asked these students what type of transportation they use to get to school each day, right? So we're figuring out how students are coming to school. Are they coming to school by bus, by car, or are they walking? Right, so one of the things that I told you is even if we don't see those total lines here, it's always a good idea to calculate the totals. So to start adding straight down, right? So 47 plus 32 plus 19, this is 98. 31 plus 22 plus 26 gives us a 79. 30. And then also add straight across, so 47 plus 31 plus 4. Right, and then we want to add both of these to make sure we get the same number. So 82 plus 73 plus 52 gives us a 207. So we want to make sure the other way we also get 207. So 98 plus 79 plus 30 also gives us a 207, so we're good. Okay, so our first question says how many total students were in this sample, right? That's always this bottom right-hand corner, so we had 207 students. Right, what percent? So if we're talking percent, we're making a fraction of students who ride the bus are, right? That's our is over of. We're just using are instead of is. Are from the Oaks neighborhood. So of students who ride the bus. So students who ride the bus is 98. So I'm in this column. I need them to be from the Oaks neighborhood. All right, so that's 32. So we said in our calculator, we'd take 32 divided by 98. I'm gonna multiply that by 100, right? And we've been rounding to the nearest 10th. So we're gonna make this 32.7%. If we look at our next question, what percent, so percent tells us we're gonna make a fraction, of those who come to school by car are from the river crossing. So by car is 79. I'm in this column and I need river crossing, which is 31. Okay, so I'm gonna do 31 divided by 79 times 100 to the nearest 10th gives me 39.2%. Now that's just a review of what we did yesterday. We want to be able to take this a little bit further and we want to say, okay, this is the survey data that we collected. How can then we predict that for the number of kids who are in the building? So based on these results, let's say that there are 1,028 students in the high school. How many students would walk to school? And this is where it's a little bit tricky because we don't see that of as clearly, right? We need to start to think through what our fraction would be. But this is of this entire survey. It doesn't give us any specifics, okay? Walk to school. So of our entire survey, we want students who walk to school. So our entire survey is 207 students, right? 207, and the number who walk to school is 30. Now, we don't want to calculate the percent right now. That's not what we need. We now want to decide what does that mean for the total students, which is no longer total of the students, but total of the entire high school, right? This is the total of the survey. This is the total of the entire high school, which means we have both of our totals on the bottom. And we're talking about those that walk to school. So now we're trying to find the number that walk to school. Okay, so these are two fractions set equal to each other. This is actually a skill that you should already know, but as a reminder, when we have two fractions set equal to each other, it is called a proportion. And when we are solving proportions, we can cross multiply, or we can multiply on the diagonal. So I can say 207 times x, which will be 207x, equals 30 times 1028, which gives me 30840. right? And this looks like something I know how to solve. This is a one-step equation, so I'm going to divide by 207. Okay, so I'm using my calculator to divide. Now, my calculator spits out 148.98. Now, we can't talk about rounding to the nearest tenth or the nearest hundredth because we are talking about human beings. We are talking about people. People we round to the nearest whole number. So we're going to say that this is 149 students, right? We would think 149 students would be walking to school out of the entire population. If 30 out of 207 are walking, then we would predict 149 out of 1,028 would be walking. Okay, so if we look at our next one, based on the results of this survey, if the enrollment is, again, 1,028, how many students would ride the bus to school? So we're going to do that same idea. Out of the entire survey, there's 207. How many rode the bus? So riding the bus was 98. But now we want to see how many that is out of 1028. So we'll cross multiply. So I'll get 207x. Take 98 times 1028. Which will give me 1,00744. I'm going to divide. All right, I'm just using my calculator. Okay, this gives me a decimal, but again, we're talking about students, so I'm going to round to the nearest whole student, so I'm going to say 487. Yeah. Now, our next one is a little bit trickier because now we're not talking about the total of the high school. Now we're talking about the total of the Oaks. Okay, so we want the total of the Oaks, right? Based on the results of the survey, if the Oaks has 500 students, not the total of the entire high school, just the Oaks. So I'm only going to look at the Oaks. The Oaks has 73. And I want to know how many will arrive by car. So the Oaks arriving by car is 22. But now if I know that the Oaks has 500 students, all right, so this is what I need to solve. So I'll cross multiply 73x. Divide by 73. I'll get 151 students. Okay. Now, there's another way that we can talk about frequency tables as well, and that is to look at data and look at a frequency table, look at a two-way table, look at the data, and see what statements that data might support. Okay, so Alvaro is interested in the relationship between weather conditions and whether the downtown train runs on time. So he's deciding, does the weather affect the train running on time? For a year, he records whether each day is sunny, cloudy, rainy, or snowy, as well as whether this train arrives on time or is delayed. Okay, so on sunny days, 167 times it was on time, 3 times it was delayed. Right? We want to look at this following and decide which statements it supports. So if we look at these statements, the first one says, when the weather was rainy, it was more likely for the train to be delayed than on time. So if we look at when it was rainy, is it more likely, so is it a larger number of delayed than on time? And that is not true, right? There's more on time than delayed, so that is not true. B says, when the weather was snowy, so I'm going to look at when the weather was snowy, it was more likely for the train to be delayed than on time, right? So snowy days, it was 12 times delayed and 8 times on time. So it was more delayed than on time, so that is true. More than half the delays came on rainy days. So delays, we need all of them together. So total there was 35, are more than half of them rainy days. Right, 15 is not more than half of 35, right? If we take 35, it's gonna be a decimal, right? Divide it by 2, that would have to be 17.5. We do not have that, so that is not true. The most delays came on snowy days. That is not true, right? The most delays were on rainy days, so we would say option B. Okay, here's our next one. A school in New Zealand collected data about the employment status of the mother and father in two-parent families. The two-way table of column relative frequencies below shows the data. So this just already has the percents calculated for us. So this is giving it to us in percent instead of giving it to us in just numerical values, but we still are going to interpret it the same. Okay, so if we look at this, a family where the father works part-time, okay, so where the father works part-time is twice as likely as a family where the father is not working to have a mother work part-time. Okay, so when the father works part-time, and then we need the mother working part-time. So the father working part-time and the mother working part-time. So we're comparing this one. So where the father is not working, twice as likely. So that is true. It is most common for neither parent to be working at all. Okay, so mother not working, father not working. This is just a relationship between the two, but it does not say it is the most common. It's just saying it is more common when the father is not working for the mother to not be working. Families where the father works full-time are more likely to have the mother working full-time. So family where the father works full-time are more likely to having the mother work full-time. And that's not true, right? Because it's more likely that the mother is not working. There are twice as many families where the mother works full-time and the father works part-time as families where the mother works part-time and the father doesn't work. So there are twice as many families where the mother works full-time, so the mother works full-time, and the father works part-time. The father works part-time. Okay, so that's this one right here. As family where the mother works part-time and the father does not work. Now here's where we have to be careful. We don't know what families these are. This isn't coming from the same column, so we're not comparing apples to oranges, so we still should stick to answer A.